Let's begin with chapter 1, Programming Basics. In this chapter, you will learn what programming or coding is and how to convert mathematical terms to computer programs. In the second section, we'll see a little bit about MathTalent. Okay, here we have section 1.1. What is programming or coding? Computer programming is the process of building an executable computer program to accomplish a specific computational task. So programming involves various concerns, mathematical or physical analysis, and generation of computational algorithms, and also analysis for efficiency and accuracy. And finally, we have to implement the algorithm, and that is called coding. The purpose of programming is to find a sequence of instructions, and so that the process of programming often requires expertise in several different subjects, such as knowledge of the application domain and specialized algorithms and formal logic. Okay, here we'll see some examples. Assume we need to find the sum of integers from 2 to 5. And to get the solution, we may start with the first one and add 3 and add 4 and add 5. And that is the mind simulation. In this way, you can get the answer, and answer must be 14. So start with the first one and add 1, another one, and another one. And in computer implementation, you'll do in this way. So programming is like a thinking. So what you think effectively will be realized in computer programming. Okay, let's go to another example. Let's try to get square root of 5. And if you are using your calculator, and if you hit 5 and square root key, then you'll get the answer really immediately. The question is, how can the calculator get the answer? It is not saved. In fact, the result is computed and exactly like this one. Here, the Q, the input is 5, and to get the solution, now we initialize our variable P, and then here P is updated, and here P plus Q over P, and the average there. Two values are averaged for given P and updated. And this iteration is done in here itmax times. For example, this is real programming in MathTalent. Q is 5. Now P is initialized to be 1. You can initialize some other value, but anyway, here initialized to be 1. And we have now 8 iteration. P plus Q over P divided by 2, and now P is updated. To see how P is updated, we try to now print out, and along with I, the iteration count and update the value. Okay, start with 1 in the beginning, so that will be P0, and here P1, P2, and updated. You'll see here now, and it is approaching to some number. After 6 iteration, later on, it's not changing. That means that just in 6 iterations, the algorithm has converted to 20 decimal digit accuracy. Here we are printing out 20 digits. So that after 6 iterations, the algorithm got the solution. That is really happening in your calculator or computers. Okay. Here, the algorithm can be interpreted as follows. Okay, we can rewrite this one into that way. Here, we need to find some number p such that p squared is q. So that first we try to make a p squared and measure the difference from q and scaled by twice of the current value, and that becomes a correction term, and correction term is now subtracted to update the value. Here the question is, this scaling factor, how can we know a good scaling factor to get the correction term, and how can we know this 2p is the right correction term? The answer comes from mathematical analysis, and later on we'll see mathematics to get such scaling factor. But at this moment, here the thing is that to get a good algorithm, you need to understand that you have to get some background around the mathematics, so that the programming consists of mathematical analysis and algorithmic design and implementation to computer algorithm, and that is called coding. And finally, you have to verify the algorithm for accuracy and efficiency. With a verification, it may have some error, so you have to verify your algorithm and coding very thoroughly. Once we have done mathematical analysis and performed algorithmic design, the next step is to implement the algorithm for a code, which is called coding. For implementation, you may use one of the computer languages, and such as MATLAB, Python, C, C++, and Java. Also, some other languages can be used. Here, you learn through the course and programming techniques using simple languages such as MATLAB and Python. Why do we choose simple languages? To focus on mathematical logic and algorithm design. If the computer language is complicated, then because of this complication, it'll be very hard for you to focus on mathematical logic. So we'll begin with MATLAB, and you will focus on logic, and after that, in the middle of the semester, we'll move to Python, because in modern society of AI and machine learning, Python is the most popular language, so that you have to learn Python. Yeah. Now we have a remark. At this moment, you may ask questions like, what is coding? How is it related to programming? Coding and programming are often used interchangeably. However, in software development industries, the coding refers to writing codes for applications, but programming is a much broader term. Coding is basically the process of creating codes from one language to another, while programming is to find the solutions of problems and determine how they should be solved. Programmers generally deal with the big picture in applications. So you will learn programming in this class. Okay, this is end of part 1. We'll continue in the second part. Thank you.